I'm here with Bo from PolymerDAO. Welcome to the show, Bo.
Thank you. Happy to be here.
Yeah, so I'm glad to have met you, Bo. You are a new GigaBrain entering the Cosmos ecosystem, and it's a pleasure that you're contributing meaningfully to the ecosystem, especially through IBC. So as far as I know, PolymerDAO is a way to get the inter-blockchain communication protocol more widely adopted to outside ecosystems.
Yes, that's correct. I would say I'm not a GigaBrain. I'll say that first. I was attracted to the ecosystem through the technology. At the time, I was working in the Ethereum DeFi space in my free time, kind of exploring different interoperability protocols. Binance Smart Chain had just come up, and now like assets and liquidity were moving between chains. There was a protocol called multi-chain. Uniswap at the time, they rebranded to multi-chain. And I remember looking at the implementation and thinking that this can't be the end state of things. They were storing their transactions in MongoDB. It's a centralized database. It claimed to be decentralized.
What do you mean? It's web scale. What's wrong with that?
It is web scale. Yeah, like it was just, I didn't appear to me to be the right solution to the problem. And I went out looking for the right solution. And what I ended up finding was IBC. Like it was the only protocol that I looked at that had a formal specification. If you don't have a formal spec, you can't have decentralized innovation. People don't know how to build, what to build, or what everything means in your protocol. And I see that as a problem with a lot of other competing protocols, which is why we chose to build with IBC versus anything else.
Right. And so when you entered the space looking at all the different cross-chain communications protocols, how was it that you converged on IBC? Compared to, Polkadot's version or, any other version. There weren't a whole lot of options at that time, but...
Yeah. It was actually pretty straightforward. I went to the docs for both protocols because I arrived at, okay, it's probably going to be, if we're going to build at that time, it was either XCMP or XMP of Polkadot or IBC of Cosmos. And when I compared the documentation for the two, I believe at the time, XCMP only had a one-pager with maybe like a paragraph and a half written about it. It's like, yeah, this is a thing. It'll allow blockchain communication between like substrate chains. And there's there's an implementation. It's ongoing. It'll be deployed in production at some point. And when I looked at IBC, there was a formal spec dating back to 2019. I later learned that history goes even further to 2016. But when I compared the two, it was no comparison at all.
Interesting story. And this is not one that's known by a lot of people, but I think, it's about time that people learn the history of Cosmos. 2014 was when Jay Kwan and Ethan Buckman started discussing Tendermint BFT. Or Jay Kwan was thinking about, like, meaningfully about how to bring proof of stake to the blockchain ecosystem, where there was only proof of work. And then 2016, he wrote the Cosmos white paper. And at that time, everything was built on Ethereum. So the thinking was all applications in the world will ever run on the single runtime. And it was sacrilege for someone like Jay to say, everything is going to be multi-chain, in fact. And there needs to be a messaging protocol that could communicate across chains. So the white paper emerged. He showed it to Gavin, and trying to recruit Gavin. And instead of being recruited, he was like, "Okay, nice. I'm not going to join you, but I'm going to build a competitor." And that's how Polkadot emerged.
Oh, okay, interesting. So I can see why he got some ideas. Yeah, that makes sense. The funny thing to me is being an outsider coming into this space. I guess I'm a boomer. I feel like a lot of the folks that I meet are a little bit younger than I am.
I actually think we might be the same age, or I might be older than you.
Really? Okay.
Many people surprised.
Okay, that makes me feel better. I feel like coming from the Web2 space, I worked at Uber. I worked at my last company was like a metrics database company. I worked on the database. At that scale, no single database can run all the computation of a company. There's some people that will talk on Twitter like, can we run a fully decentralized Uber or a fully decentralized Twitter? Unfortunately, Uber internally runs, I think, almost 100, 3 digits number of different database or storage systems. And they run this at an incredible scale. I think at the time I was there, just on the logging side, we're running the largest number of fully maxed out Elasticsearch clusters in the world. And at that, it would be almost impossible to imagine like blockchain scaling to that throughput. Like, sorry, Anatoly,
without giving up significant things like decentralization and security.
Yes.
Which we've seen, which is why it's a lot of halts.
So like to me, like the app chain thesis, now they have like the roll app or like roll up app roll up thesis. Made a lot of sense because I was like, this is the only way to scale. Like you can't scale a single database to like handle all the computation in the world. And also you can't optimize a single data. That's the other thing I wanted to mention is that you can't optimize a single database to be good at everything. That's why there's so many flavors of databases at Uber, because they're all optimized for a specific workload.
Right.
Ultimately, it helps Uber save money on hardware, and that feeds the bottom line of the company. And I imagine that in the future, when blockchain is at truly like full web scale, that you have a lot of specialization. Like right now, it's kind of like not clear like why app chains matter to a lot of folks. But I think once app chains start needing to specialize into different functionality, different workloads, that's when people would be like, oh yeah, this makes a lot of sense. Like this is obviously the right way to scale.
It's interesting how you mentioned how there's specific databases that are application specific to whatever use case they're storing data for.
Yes.
So, and one of the realizations that the Handshake developers had was that there is no database that is specialized for blockchain data. As an industry, we still don't have that yet.
Yes.
I mean, in Handshake, they have the Urkel database, and that's an interesting concept. But maybe we need more of that, right? Maybe like level DB isn't necessarily, or maybe it's too bulky for what it is that we need for scalability.
Yeah, absolutely. It's also from like anecdotal and personal experience. Like during my time at Uber, although it was before my time when they first started on this project, but they were writing all of their metrics just for monitoring data at the company to a bunch of Cassandra clusters. Without describing what Cassandra is, just know that it's not specialized for the metrics workload. And they were using a ton of hardware. And the task for the metrics team was, how can we save on hardware costs by making a database that's optimal for this specific workload? And similarly, even though IBC network is still burgeoning, it's still growing, it's still homogeneous, it's the topology is changing, we wanted to be forward-looking with the way we looked at IBC as well. So we came into space and we were thinking from the lens of, if IBC is going to be the interoperability standard universally across chains, how do we build a blockchain that specializes in the IBC work?
Tell me about the design thinking. Why does there need to be another blockchain that, I guess, exports IBC to other ecosystems? The thinking was IBC was supposed to be direct chain to chain, no matter what type of consensus they're running. Why does there need to be a PolymerDAO in the middle or a Polymer hub?
Yeah, we thought about the same thing. I asked myself the same questions when we were initially exploring. I think the problem is less obvious when you're looking at it from the lens of a homogeneous network. When every chain has the same consensus, when every chain has the same data structures internally, things work fine. Things work great. You can have direct connections. Everything's performant. When you start dealing with a heterogeneous network, so now you're dealing with, okay, maybe on the EVM, how much does it cost to verify something that it's hashed using a specific hash function that's not EVM friendly? Then it becomes a little more apparent that, wait, we need to change some things, change some variables up. It's not necessarily, in the middle hop here is not necessarily a translation layer. It's just making some performance optimization so that this IBC specification, this IBC standard, can be scalable and performant across this heterogeneous network.
Let's deconstruct that a little bit. It's going to be a technical podcast, and we're going to talk about how it all gets broken down. So can you help our listeners understand what the key components are for a chain to speak IBC with another Cosmos chain without the, let's say, the source chain being like an EVM chain like Ethereum or Avalanche or something like that?
Yeah, I think to understand this problem, the mental model, you need a mental model for thinking about IBC itself without even thinking about how to integrate into a particular chain. So if we look at IBC and we think about what is the interoperability model, how does it relate to networking in like the Web 2 sense? you'll start to see many layers start to appear. If we were to look at IBC, deconstruct IBC, you would get this application layer on top. These are the application standards of IBC. Some of you are very familiar with, like ICS-20 for token transfer, interchain accounts, and so on. And then beneath that, you have the transport layer of IBC. This is analogous to TCP/IP in the Web 2 networking side. And this layer encodes all of the connections, channels, packets, essentially makes sense of all the conversations that are happening between all these different chains. And it is a standard for how do you commit to all of the messages that you want to send between any number of different chains. Therefore, any chain in the IBC network that implements the IBC specification will be able to produce a commitment that can be understood by every other chain in the IBC network. Just like how in TCP/IP, if your node implements TCP/IP, you will be able to join the internet and chat with any other node. And this is important here, either directly or indirectly, without any gatekeeping, without any vendor lock-in. Essentially, the internet is borderless. And at the state layer of IBC, you have you have the problem of how do you move state from one chain to the next. And this is kind of very consistent in the Cosmos ecosystem because you have just a single type of consensus. When you move between ecosystems, you start to need to develop other clients. Fortunately, the IBC has been forward-looking. They have a very loose client definition. You're able to produce all sorts of clients that can map to the consensus of Avalanche, the consensus of substrate chains, Polkadot. And you can also map to like the consensus of modular blockchains on Celestia, rollups, rollapps, whatever you call it. So thinking of it from these three layers, you have to implement if you want to do it natively, you have to implement all three layers, application, transport, and state on the respective chain. And that's difficult to do. In some cases, you will be exposing the internal implementation details of that particular chain with the rest of the ecosystem, which is also challenging as well. So just to solve this problem, Polymer is going to come in the middle as a middle hop in multi-hop IBC, and essentially, with the modular design, abstract away or create or decouple the application layer from the transport and state layers of IBC, make the boundary between the application and transport layers asynchronous instead of synchronous. Because if everything's on the same chain, all of that code gets executed all at once. If we separate the application layer from the transport layer and the state layer, now you have separate execution or asynchronous execution of the transport commitment on behalf of the chain that we're talking to. Therefore, Polymer allows all the chains in the IBC network, even if they're not IBC compatible, to be able to produce IBC-aware state transport commitment that can be understood by every other chain.
I'm wrapping my mental model around what you just said. So to run a Tendermint light client, you basically need to track the state of the blockchain and check which validators are currently validating for the network, right? To see if there are any changes and which ones you can trust. So that's part of the IBC language. And when you're converting ETH-speak or EVM-speak to this, like how does that change? And how do you make ETH-speak so-called IBC compliant?
It's quite challenging. We've been working on it for some time.
But what are the material differences?
So there's a few differences. Internally, the data structures that Ethereum use are not IBC friendly. For example, Ethereum will hash the keys that you're writing into the state before writing them. Therefore, you have a random location for the ordering properties are kind of distorted. It's very difficult to generate something called a non-inclusion proof or proof that something was not written to state because there's no ordering. You have to download a lot of data in order to prove this property. And then because this property is necessary for IBC timeouts, it makes it tricky. So that's one technical detail that is challenging. The other detail is that Ethereum doesn't have single slot finality. So how do you map something that doesn't have single slot finality with a protocol and network that expects single slot finality? We have an internal protocol to us that we take. So we have a native light client for Ethereum where we verify Ethereum consensus. If you want to be very secure, you can wait for 2 justifications of an Ethereum block, which is finalization, about 12 to 16 minutes. If you're a little riskier, if you're okay with trading off latency with security, you can allow us to route data at a lower latency, but you have increased risk of reorgs and such. We take this native light client that has forks, can reorg, we map it to a virtual light client. This virtual light client defines essentially a fork choice rule over the native Ethereum light client. So this changes the view, or the IBC network now has a view into Ethereum state. So you have a view into, if you want to look at it at, I don't know, at the finalized height, you would always use the doubly justified view. If you want to have a view at like, faster latency, but obviously risky, you can have a view into Ethereum at a more recent block height, but then you have like the problem of reorgs. We also handle reorgs for you. So in a way, our view is always mapped to the canonical Ethereum view. So as blocks get finalized, we'll reorg that view for you on your behalf. You always have a view into, or like the best possible view into Ethereum state.
Let me just break down Ethereum's fork choice rule, which is, it's still Ghost from the last time I checked in with them. It's still Ghost, right? So, right, Ethereum validators are going with the fork choice rule that has the most attestations, effectively. And how does PolymerDAO's fork choice rule differ from that?
So there's a caveat here. I would say that because we're using the like Altair Light client, there's a number of teams building with Altair Light client. Altair Light client is actually a sub view to like the full view of Ethereum state. If you wait for true justifications, that is considered final. The entire Ethereum network has attested to that. If you want to go lower than that, you're getting a view into basically 500 validators, and they rotate out at some clip. And you're getting a view into what they see of the Ethereum network. So this is not a global view of the Ethereum network. It's a local view of these 500 validators with respect to the rest of the Ethereum network. And because this local view it's very difficult to weight all the different forks. The fork choice rule we applied in Ethereum's case is actually an aggregate view. So we say that we'll aggregate all the forks. We're actually not sure, at least with the 500 validator view, if there was a full view of Ethereum of all the validator set and that were possible to do efficiently, then we would use that instead, and we would be able to define a more canonical fork choice rule. But for now, we're defining an aggregate fork choice rule where we'll aggregate data from all these different Ethereum forks. You have an aggregate view into Ethereum at lower latency, and at higher latency, you always have the canonical view of the Ethereum chain.
Got it. And just so anyone who's new here who isn't fully aware, in contrast to that, the Tendermint fork choice rule is none. That it doesn't fork. So that's how the two differ. Now let me ask you this: in a stateless network like Bitcoin, how would you translate that into IBC speak, where it speaks pretty stateful language?
Meaning on the Bitcoin network?
Theoretically, let's say PolymerDAO now supports Bitcoin, and now we could transfer native Bitcoin magically, let's say, into the Cosmos ecosystem. How does Polymer support like stateless networks?
So I'm going to make this up on the spot. I feel like it would be difficult to implement the IBC framework within Bitcoin. I've never tried to. I know there's some scripting languages for Bitcoin, but I've never dug deep enough to have context there. But I believe that, this was published as kind of like a troll post, but the Rollkit guys, the Rollkit team / Rollkit/Celestia team published a post on building roll-apps using the Rollkit on top of Bitcoin, or sovereign roll-ups on Bitcoin. I can kind of see a path where you could have a sovereign roll-up on Bitcoin that kind of has knowledge of Bitcoin accounts and balances, and the sovereign roll-up could potentially, connect via IBC into the Cosmos network and kind of act as like some sort of like sovereign roll-up bridge. I don't know exactly. I haven't, thought this through, but it feels like that's a possibility. Also know that the Babylon guys do have a Bitcoin Lite client. I believe it's working.
Yeah. So here's one piece of consensus that very few people in the proof of stake ecosystem recognize, which is it's really hard to correctly do Merkle proofs on Bitcoin such that you can actually leverage the security of Bitcoin. That being said, if that part isn't done, all you do is open up new attack vectors for the chain that is attempting to borrow Bitcoin security. but it doesn't actually affect the Bitcoin network whatsoever. That's what makes Bitcoin robust, but sadly implemented wrongly, the other networks that ostensibly depend on Bitcoin security will not inherit Bitcoin security.
Interesting.
Without those proofs.
Okay. Now I'm inclined to want to dig into Babylon Team's implementation of their client. Because I remember chatting with them recently, and they were saying that anyone would be able to publish proofs or kind of Bitcoin headers into this Bitcoin Lite client, not just through Babylon Chain. Therefore, people can then look into these proofs, look into Bitcoin state, and verify that some data was checkpointed, like some consensus state or blockchain state from all these chains that are kind of connecting to Babylon. Babylon's doing this aggregation. You would be able to check this independently with Bitcoin security. I'm curious what the Merkle proof checking.
Right. Yeah. If the assumption is that Babylon does in fact do this, but doesn't, and an attack is discovered, then the only chains that lose are the ones that assume this. That's all. But anyway, I think, Bitcoin and, proof of work networks with UTXO systems completely maybe longer down the roadmap for IBC adoption.
Yes.
And so we're strictly talking about proof of stake land now, where even though it's non-trivial to create IBC compliance across these different ecosystems, it's still possible compared to Bitcoin.
If Bitcoin had an expressive enough virtual machine, I don't know what it would take to have that. If it did, I can see IBC work. I think it's just, from my weak understanding, I think it's just the constraints of the scripting languages just may not allow.
Yeah, or it could take some pretty knowledgeable autists to figure it out. Okay, anyway, we're extremely off topic. So one of the interesting things that we talked about, you, myself, Christopher goes on the IBC Turns 2 podcast, that we did a couple of weeks ago on the Interchain Jam, was that IBC lacks an in-protocol incentivization mechanism to allow for relayers to be rewarded so that they could be, continue their relaying operations, basically. I think that's one of the pitfalls of the overall design. So how are you thinking about solving that?
Yeah, so that's definitely true. I think in the ecosystem as it stands, chatting with validators or infrastructure operators, I think the sentiment is that they don't like running this stuff for free. It's a business, they need to make cash, have some cash in.
Yeah, you can't be running these things
at cost.
Yeah, or at negative EV.
Yeah.
At cost is bare minimum.
Negative, yeah, exactly. There's a specification for packet level incentivization. It's ICS 29. It's a fee incentivization framework. How it works is it allows a relayer, because you need to be able to escrow some funds on the source chain. This is the reward. This is the incentive. And you need to be able to pay out this relayer that has then forwarded this packet on the destination chain. So they've solved the relayer registration problem where they have a protocol for a relayer to register a pay address on the source chain so that they can be incentivized for a packet that they relayed to the destination chain.
So is this a sort of fee model where they take a small percentage of the transaction that's being relayed?
I think it could be extended to that. The interesting thing about IBC is that application standards are malleable because everyone can implement it how they want. There's a formal spec, but you could potentially modify this application protocol for fee incentivization to deduct a percentage of the packet value for token transfer. But that would make it very you'd have to peer into the packet. You have to know what the packet means, and then you have to say
why not a small fixed fee that's reasonable for transferring anything?
Yeah, that you could make that as well. You could have I need to restrict that you have to supply a specific daemon, but that would actually be up to the chain themselves to implement. The way it works right now is you allow anyone to escrow fees on behalf of a packet, and these fees are additive. So there is a send fee, there's a receive fee, ACK fee, timeout fee. So you're able to specify for each of these fields do I want to escrow some amount for each of these operations? For example, like if you wanted to say, have a send and forget mechanism, so you want to send a packet, maybe you don't care about the result. You would incentivize the receipt of the packet, but you would not incentivize the ACK or the timeout. Or maybe if you want the timeout, you want to incentivize that as well. If you don't care about it, you don't have to incentivize it. Now, if you care about all these things, you would incentivize all three. You would say, I want to escrow some denom, some fee, all these three fees. But the important thing to note, and I think it's kind of lost a little bit, is that you can escrow any token. So any denom can be escrowed. The issue then becomes, how does a relayer know that what they're getting paid is actually enough for what they're spending on? There are different tokens that they're spending and getting paid in. So there's like additional infrastructure work that will be required to actually like make this all work. Relayers have to be informed of like, oh, what are the prices of all these different tokens? So they need some sort of like pricing oracle. Like users would need some sort of recommendation, because when you use like MetaMask, you'll see like, hey, if I supply like this much transaction fee, then I'll likely get it processed in like this amount of time. And that infrastructure doesn't exist. And I'll say that after looking at some relay implementations, that for there to be game theoretic relaying based on some pricing of different assets, network utilization, that it becomes quite tricky to implement. And relay implementations are not considerate of that now. So there's a lot of like grunt work that needs to be done to take this to production.
Let me ask you this. If Polymer is meant to be the hub for exporting IBC, then why wouldn't the tokenomics of PolymerDAO be one such that it is the token subsidy for this work?
You can do that with.
Are you doing that?
We may consider doing that. I think because of the way the fee protocol is designed, and we're also working on expanding it, which I'll talk about soon, is anyone can escrow fees. So you could potentially escrow Polymer tokens. Or hub, like if we wanted to, like let's say there's, in a game theoretic mode, if you think about like what does it cost to submit a client update, like what is the latency for it, submitting a client update in the Cosmos is pretty much like not very expensive. So like relays will do it pretty often. Submitting an update to Ethereum can be kind of expensive. So unless there's incentives, maybe no one will want to submit a client update. So maybe to incentivize, like, reduce the latency of certain connections to like more expensive chains like Ethereum, we may consider like, oh, well, we'll provide some incentives through this decentralized incentivization protocol for relayers to keep the latency low and the user experience good, because lower latency is usually better UX.
Yeah. Okay. So that being said, it's a perfect segue to talk about the tokenomics of PolymerDAO. What does the token do?
The token is just used to pay for gas on the Polymer hub. I think the principles of IBC is that we're not to be value extracting. Like if the transport layer of IBC does not know anything about the application layer. So the applications that build on top know what is valuable and are able to transport value without necessarily, and this is obviously the issue with incentivization, without actually giving any value back to the transport layer. But we want to allow them to be able to incentivize the infrastructure providers to do this, because in a fully decentralized setting, you want to be able to allow for this type of incentivization. But so Polymer token is not Polymer as a middle hop in IBC is also not technically value extracting. We're just only executing the client updates. Polymer is basically maintaining knowledge, all these different chains, and some of this knowledge is challenging to keep up to date with, but like Ethereum, for example.
Let me just stop you right there. So as a validator of Polymer network, I assume you have to run these full nodes or light nodes of the supported chains like Ethereum.
You don't necessarily have to run a full node. You can. Or
do you assume that most of your validator network is just going to use Infura or some centralized provider?
They can if they want to. Because we're verifying the headers of the chain that we're connected to. It's much more difficult to like forge an invalid header. Unless the starting point was untrusted. If we're starting from a trusted starting point, then through social consensus, and then it's very difficult to forge anything. It's different from an approach like Axelar or Layer 0, where you're observing the header of a chain. You're not doing any verification. If all you're doing is observing and voting, then what the information that is supplied needs to be correct. If you're validating or verifying the actual headers, information that you need to be supplied is there's less of a risk of forgery and yeah.
Yeah. Okay. So right. So again, as validators of the Polymer Hub, is that what it's going to call Polymer Hub? What's their job? Is it that if delegators are voting in governance to support a new ecosystem, like let's say Solana or something, what do the validators have to do? What's their job?
Their job is to run the Polymer node. The Polymer node runs like clients of all the chains that it's connected to. Therefore, it verifies the state or the state transitions of all these different chains. I like to think of Polymer as a transport hub, meaning that the main goal of Polymer is to provide the IBC transport layer to applications that live on all of these different chains so that applications can be standardized across all ecosystems, across this transport standard. We actually aren't necessarily going to want to make ZK clients for every single chain because it actually takes a lot of resources and is a large team or maybe not large, but a knowledgeable team and a lot of effort to implement these clients. We want to work with client teams. So that's why I've been working on client incentivization. I kind of see not just Polymer Hub, but the IBC network in general as a client marketplace. So if we can provide the right client incentives for folks to basically verify state from chain A to chain B, then we can have partner with these client builders and have decentralized innovation to expand the IBC network. Because one team trying to build all these clients by themselves is not really going to scale.
Let's think about this for a second. I enjoy theory crafting, right? Because could there be a consensus mechanism where you could submit proof of relaying, and then by doing that, you get a reward from Polymer tokens or something, or in protocol incentivization for relaying between chain, this and that?
I mean, I'm sure you can. With the way I like to think about blockchains is that they are giving you proof of something, whether it's proof of consensus, whether it's a cryptographic proof, whether it's an optimistic fraud proof. They're proving something. You could have some sort of oracle, but the oracle is kind of just a single observer, maybe multiple observers. You can have someone observe relaying, and if they're able to attest to that action, you can say that this chain or this set of observers are relaying proof attesters. But then you're trusting this another entity to attest to what's happening on a different chain, which is in my opinion not ideal. In my opinion, I like the way the ICS 29 spec is implemented, although there's not a lot of adoption. There's some blockers, channel upgradability and such. But I like that you can basically show a proof from a chain that you're already connected to that you did some work and pay out. Meaning that you're not introducing additional security assumptions on some other third party. You're just relying on the consensus of the two chains that are already talking to each other. And that security model is the minimum of the security of the two chains.
Right. So somehow you could submit a proof of the state of the two chains that you relay for and say that you've done that.
The state of the two chains. Oh yeah, the
Or imported into Polymer, I guess.
Yeah. If Polymer is already connected to all these chains via the IBC standards, we would be able to see that, okay, on that chain, there was a commitment for, some packet. And
yeah.
So because with IBC, as you're aware, and especially with multi-hop, you can see that every connected chain in the IBC network is either directly or indirectly aware of the state of every other chain, which is also really cool and really important. Obviously, at varying degrees of latency and security, because the more hops, the longer the latency, and the more hops, also the security becomes a little more fragile because you have more chains in the middle, and every chain may have a different level of security. But it is possible to show proof that I did this relay on this chain all the way over here, and maybe you're not directly connected to them, and then give me some incentives, or we can then construct some incentive mechanism for that.
So I think that's deep enough. We've gone into the rabbit hole. In the Web 2 context, and this is my naivety coming out about how Web 2 works, I only understand at a 30,000 foot level that TCP/IP is the communication protocol for all websites, right? It's one that servers are routing to clients when they make a query. How is that network functioning without any sort of incentivization? And why is it different in the blockchain context?
I don't see them as different.
But TCP/IP runs without anyone paying people to run it or to use it, rather.
I actually see the mechanism similar to how like my mental model for that is actually the same as it is for the IBC. Because they decided that in the IBC at the transfer layer, you have this transfer application separation where the transfer layer essentially cannot technically capture value, but can indirectly be incentivized because, you want to incentivize folks to, basically like light up these physical cables. Like there needs to be some sort of like economic incentive for like some country or company to go into the ground, like dig a hole in this seabed, like, string this like giant cable along to connect all these continents, which is actually, how the internet's connected across different countries. It's indirect incentives. So because
but the business model that emerged was ISPs or like telephone cables.
Yeah.
So do we have an analog of that in the blockchain space?
The analog to me is that IBC connections. So IBC connections are two blockchains talking to each other. I see that as the physical cable. I see that as a physical cable connecting chains, and I see the transport layer, which is all the IBC core specifications, as the TCP/IP on top. And in this model, like the transport layer, the client layer, like the state layer, needs some way of being incentivized, which we kind of discussed earlier about the various incentive mechanisms that we can indirectly incentivize or have people escrow fees. They will pay these providers to do this work. In the Web2 world, a lot of these companies are getting like indirectly benefiting from all these use cases that are being built on top. Obviously, like as a Verizon doesn't know that you're signing up for your Netflix subscription. Verizon not saying like, hey, I know that you have a Netflix account, you're paying them like $6 a month. I'm going to step right in the middle at the protocol level and take a percentage of those fees. There's money going around because of all the utilization between these companies and their relations, kind of like this B2B thing. It's not a perfect mental model, but it is somewhat in a way that like, even though the transport layer of IBC doesn't have quote unquote like value capture, it is able to be incentivized. And that's kind of the same model for running Polymer Hub. It's like it's a minimally value extracting middle hop that just provides this transport standard, IBC as a transport standard, as a service to all these different chains.
Yeah. Would you say that the blockchain paradigm is different because it's more peer-to-peer instead, where pretend a chain is a peer, then chain-to-chain is peer-to-peer?
Yes.
So there's not really any centralized like telecom companies or like ISPs in the middle extracting value from that, right? We don't have like T-Mobile. We don't have cable companies rubbing their nipples at us. It's gonna take 4 weeks.
Oh yeah, when they like, I guess like I was just remembering not having Horizon files and like waiting for them to like, I guess they had to have enough like willing to pay customers in a certain region to be like, oh, there's all this demand for files. Like, okay, maybe it makes sense for us to go out and then like lay some cable.
Right. Yeah. Anyway, South Park did a good depiction of what it is like working with a cable company.
I guess you are kind of like, as a user, you're incentivizing the cable company to relay your data, but you're also paying for the applications on top. So it's like you're using an application, Netflix or whatever, but you also have to like pay for like incentivize the data relay.
Yeah.
Which is kind of like, I guess, like the IBC model as well, in a way.
Got it. Yeah. Great. So are there any upcoming milestones that listeners should be aware of? Are there announcements, housekeeping items that you want people to know about?
We're doing IBC Summit or Summit for IBC, and we're doing a demo of our product, the first demo, and not so long afterwards, we're also going to be doing a private testnet of our protocol, try to get our protocol in the hands of developers. Another interesting thing that I would like to mention is that because we're implementing the IBC protocol or the IBC standard, we're able to build tooling and be to work with the ecosystem. So our tooling that we're building is not specific to us. The tooling that we're building is beneficial to all IBC-enabled chains. So we're working on this IBC SDK to simplify the dev experience of building dApps or IBC-enabled dApps across all these different chains. The Cosmos SDK is great for building app chains. There is nothing right now for building dApps that span across multiple chains. And some of our collaborators have mentioned this as a pain point. Like, how do I spin up the infra for like 4 different chains and like set up all the relay infrastructure? Like, how do I even test?
You mean to deploy the same application multi-chain across different Cosmos apps, app chains?
Well, let's say you want to, build and iterate faster. You're developing an application. You want to test it. You want to build it. You want to iterate quite quickly. If you want to deploy it across a number of different chains efficiently, and also set up relaying locally for all these different chains, it's very difficult. I did it once for testing interchain queries across like some chains, and it was challenging. Like, you have to manually set up like relayer configurations. You have to get an image or build a binary for all these different chains. You have to spin up all these different chains, configure them. You have to then deploy your contract specifically on all these different chains yourself using like tooling specific to like different chains. Like, it is not an easy task. This IBC SDK makes it magical. You just press a button, everything comes up, and all you have to worry about is deploying your application. And that's the developer experience that we need if we want more people to build in the Cosmos. Yeah. If the dev experience sucks, no one's going to, like, sure, you can build app chains. The dev experience is pretty good. But for building the dApps, it's not that great.
And just before we close out, very quickly, you guys are building ZK Mint.
Yes.
Talk about that at just a 30,000 foot level.
The 30,000 foot level of ZK Mint was, we needed to verify Tendermint consensus on Ethereum, and that is very expensive. There's some ways that you can compress.
Because of all the signatures.
It's not just the signatures. So I think the misconception is that signature verification is the bulk of the cost. If I recall correctly, when we did the profiling, signature verification was maybe 20 to 30% of the cost. That alone was already like way too expensive. It was 70 to 80% of the cost.
How much gas would that have cost just for signature?
I think it's on the order of I think $1 million gas per. It was like something ridiculous. It was a very large number. I don't recall off the top of my head. But yeah, just that alone was incredibly expensive. There's protobuf serialization and deserialization. You have to do a lot of hashing to kind of like check it, or like inclusion of different validators, like check the weights. They get to prove that the validator is in the validator set hash. There's all these things you need to do, and all that accounts to like another like 70% of the cost. And we're like, and there's some protocols that are working on just the signature verification side, not thinking about the rest of the protocol. We're like, how can we turn the entire Tendermint light client, not just signature verification, like the full non-adjacent header verification algorithm, into something that's one, easy to prove and easy to verify. So you can prove Tendermint consensus without ZK Mint using the raw Tendermint headers. It's just, you have very long prover times. It takes a while. You have to implement a custom circuit just for protobuf serialization and deserialization. That alone is a lot of engineering effort, and it's not. You have to make sure that it's right. You have to get it audited and so on. So we decided to think about, or try to reimagine, what does consensus look like for something like Polymer that has to sit in the middle of all these different heterogeneous networks. So ZK Mint, although it's a marketing term, what it really is, it's multi-signature Tendermint. So we're able to produce multiple versions of the same header that are optimized for verification in different execution environments. And it goes back to the idea of Polymer being adaptive and flexible middle hop that can optimize for the execution in different target execution environments, therefore making IBC scalable enough to bring to other chains. And then, as I mentioned earlier, this problem isn't apparent to folks that aren't trying to shove IBC into all these different other chains.
Sweet. So when can we expect Polymer to launch mainnet?
I think we're going to target, I want to say optimistically, end of the year, pessimistically early the following year.
Okay. And what are some of the implementation hurdles for launching before end of year?
I'll be super transparent here. One of the major implementation hurdles is the adoption of multi-hop IBC. So we have an official spec. It's currently being reviewed. It will be upstreamed very shortly at the spec level. I believe the ICF IBC Go team is targeting getting the implementation in by IBC V9. I'm assuming that's probably going to be sometime next year. And then you have to wait for people to adopt the actual multi-hop implementation. So that would be probably the biggest blocker to being able to use Polymer as a middle hop. And I think it's also valuable for their Cosmos chains. For example, the Cosmos Hub could benefit Like people have been talking about the hub being a hub for so long, and now the hub can actually be a hub. You'll be able to define channels over the hub, and then let's say like I want to have a lot of connectivity. Well, I just connected the hub, and now I have a lot of connectivity to all these other chains. And like Osmosis too. Osmosis has a lot of connections. And now chains will be like, oh, if I want to be able to connect all these different chains, I don't need to connect directly. I can just connect to Osmosis. Now I can talk to all these different chains. So I think it's beneficial for a lot of other Cosmos chains as well. So yeah, when the time comes, please upgrade your versions of IBC to your app chains.
All right, and that's it. That concludes this episode of Interchain FM via the Interchain Jam series. Thanks for tuning in. See you next time.